Okay, so hopefully everyone can hear me. Welcome everybody, and great to be here at Purdue, such a beautiful campus. I won't say anymore since this is being recorded, so I won't get in trouble at home for praising Purdue too much. But my name is Ramez Hodge, and I'm a faculty member in Civil and Environmental Engineering at the University of Illinois, Urbana-Champaign. And my co-authors on this presentation are two of my graduate students, Hanan and Yuja. Hanan's actually using this project as the first third or so of his dissertation. So this project, which is becoming worse and worse named as it goes on, is called Development of Porous Asphalt Mixes for the Southern Lake Michigan region. My expertise is in transportation engineering and work on sustainable and resilient infrastructure for roads and other transportation infrastructure. We'll go to the next slide. So over here, what you're seeing are basically a quick description of why we want to use porous asphalt. So porous asphalt mixes are essentially asphalt mixes that you would see out on the road, except they've had a lot of the fine aggregate, which are rocks and basically sand, removed so that they have a larger air void network. And the reasons for doing this are mostly to improve drainage so that water doesn't collect at the surface. If water collects at the surface of an asphalt pavement, it can lead to vehicles hydroplaning, which causes a safety issue. So porous asphalt reduces that. It also reduces the noise. And it can even, this is not a concern at all in Illinois, but in places with very deep water tables, it can actually replenish the water table as well. Again, not a problem for us, but some communities use it for that as well. So going into this research, yeah, we can go to the next slide. We really wanted to understand how porous asphalt's been used in the region. So we contacted the city of Chicago, their Department of Transportation, and turns out they've actually paved a lot of porous asphalt in certain parts of the city. Those parts being mainly side roads, alleyways, those kind of things, not any major roads because it's usually not that great for high traffic areas. And they basically told us, which we also confirmed with our literature review, that it's been really, really poor performance over all of these mixes. They haven't been happy with porous asphalt, and they don't really consider it a technology that they're looking to expand. And so we wanted to understand the better reasons for that. We did do quite a bit of literature review to understand some of the reasons for that. And in terms of those reasons, it was mainly discovered that construction and maintenance were the problem. So that's why I say the title of this presentation became worse and worse, because we really discovered we don't need to develop a new mix. We actually need to understand the problems with construction and maintenance. So they ended up giving us 7 sections to sample throughout the city. And we did sample cores, 4 to 6 cores from each of those sections, and did an analysis of those cores. We'll go to the next slide. And for this analysis, we focused on both non-destructive and destructive testing. So looking at the surface and the structural properties, as well as looking at some of the performance of the material. We'll go to the next slide. So here you can see some of our results. I just put a snapshot of some of the examples up here. On the right, I want to make sure I got that right. So on the right, you are seeing some of the basically texture and surface parameters. We obtained these using close range photogrammetry, which for those who aren't familiar is basically taking photos at different angles and then using them to reconstruct a 3D surface of the material. And what we found is essentially that you can see that this graph, those top 2 graphs are related to the roughness of the surface. So roughness of the surface basically tells us if you have a smooth pavement surface, that's really good from a noise and kind of rideability perspective, but it's really bad from the perspective of actually creating friction between your tire and road and stopping. So that's what we saw in the top. And then the bottom 2 are more interesting because we saw a better correlation with time that really showed that the surface is degrading. So these have to do more directly with the kind of properties of the aggregate in the porous mix. So what we saw is that very clearly the aggregate is degrading over time. The older the mix, the more you see those parameters degrading. And we did see fair correlations with those, which were all as expected. On the gradation and binder analysis, which is on the left, what you'll see is that there was a lot. This is just one example of a mix that was constructed in 2020. So not a very old mix at all. We sampled these in late 2021. So what we observed is that there is a discrepancy in amount of asphalt binder between the top and bottom, as well as the air void content and the amount of fines. So because it's such a fresh mix, we can attribute a little bit of that to accumulation of dust, which we found from the literature is basically the biggest enemy of porous asphalt. If dust starts to accumulate, it gets clogged and the drainage capacity just gets reduced, which leads to water being retained in the mix and creating damage due to moisture. So we also saw the binder content issue, though we think is more of a construction issue because typically binder content in different parts of in different layers of the mix shouldn't change over time. So we think that's more related to construction and how difficult it is to compact these mixes properly, especially for the contractors in the region. We'll go to the next slide. So I'll talk a little bit about the conclusions here. Overall, the experience with porous asphalt shows very rapid surface degradation and segregation during construction, as well as segregation of fines during the life. Again, we've seen that even more pronounced with some of the older mixes, which I'll have results for all very soon. And in terms of future work, what we really want to do is just finish analyzing all of our data. And we plan to submit a paper this year for the TRB, which is Transportation Research Board annual meeting in DC in January. So if anybody's there, we'll be happy to share our work with you, assuming they accept it for that conference. Other than that, I think I can hand off to the next presenter and be happy to answer any questions in the break and in the reception.
Thank you.